Good morning, Auto One. I hope you guys are well. We're going to be talking about how we initiate the four-stroke cycle, the power of the four-stroke cycle, and then what's called a compression test, by which we can measure. We're measuring the compression of the engine, but we'll talk about it as a way of evaluating the power potential of the engine. Okay, so we're going to start down here on the floor, and what I'm going to do is I'm going to show you when you turn a key to start an engine. I'm going to show you what's going to happen. So if you look down here, I've got an automotive 12-volt starter motor, and just making sure I'm in the video here. So this is a electromagnet starter motor. I have a 92 GMC as opposed to a permanent magnet starter. This one's heavier, old school, etc. And so I'm just trying to show you how the four-stroke cycle starts and the engine actually starts. So this is a jumper pack, which is basically just a strong automotive 12-volt lead-acid battery. And move over this a little bit so I'm in the picture a little better. And on this starter motor down here is where the battery positive lead normally goes. And the negative is just grounded to the starter by virtue of the starter being bolted to the engine itself, and we'll look at the engine over here in just a moment. So what this is this is just a little momentary on switch, just a push button, spring-loaded momentary on. So when I push it down, we get what we call continuity between these two leads. That means we get a continuous path for electrical flow. When I release it, we break the contact, and we have no more continuity, no more path for electrical flow. So when you go to start the car, whether you're turning the key to start it or whether you're pushing a push button start with your foot on the brake pedal, battery power is being sent into what's called a solenoid, which does two things. Moves the gear out that's going to mesh with a flywheel or flex plate. This is called a flex plate. This is a automatic transmission flex plate. It does have teeth for ring gear. This one happens to be cracked and broken, and the teeth are worn away. You can't probably see it from how far back I am. But in this case, on the starter motor, there's a gear. It's going to come out and engage this. This is bolted through these 6 bolts to the back of the crankshaft, and it's going to begin spinning the crankshaft and initiating that intake, compression, power, exhaust, four-stroke cycle. Okay? So again, you're going to turn the key or push the button. You're sending battery power into a starter motor. The gear is engaging this. That's bolted to the crankshaft. It starts spinning. So I'm going to take the place of your key switch or your push button switch with this momentary on switch by just attaching it there, and this lead right here would come from your ignition switch. What's not in the picture is the ignition switch or the push button switch. What's not in the picture is what's called a neutral safety switch, which doesn't allow the car to start unless the automatic transmission gear selector is in park or neutral. What's not in the picture is if you have a manual transmission car, you have to push the clutch in, and it has what's called a clutch safety switch, or it won't crank the engine. What's not in the picture is an anti-theft system, which will not allow you to crank the engine unless the key that you have has its little identifying chip in there. So when I push this button, battery power is going to engage the starter flywheel, engage the starter pinion gear with that flywheel. It's also going to push a little disc over, which sends power into the starter to spin it, because we don't want this gear to spin until it's engaged with the flywheel. Now, obviously, I'm not going to hold this up here and let it actually engage and spin, but I'm just trying to show you how it works. So here we go. So there it goes. So if you can see, I'm going to grab the camera, and I'm going to do it one more time, and I'll grab the camera and bring it down by the gear. And I just lost my connection, so I'll put it back on. Here we go. So the starter motor has so much torque or twisting force that when I engage it, a lot of times it knocks my wires right off of the starter. So here we go again. I'll hold it down. So I'm going to grab the camera and bring it down here so you can see a little better. Okay, so what I'm going to do is I'm going to go ahead and hold this camera, and I'm going to put my foot on the starter so it doesn't move on me. And I'm down here pretty close so you can see the gear come out. Here we go. 1, 2, 3. So every time I push this remote starter button here. This is just a momentary on button. You see that gear. Okay, so that's what's happening when we go ahead and start an engine to initiate the 4-stroke cycle. One thing I want you to see is I'm going to do it one more time and not hold it. And you're going to see how much twisting force this thing has. Here we go. Ready? 1, 2, 3. So it just flipped over and the leads fell off. And all right, so we're done showing you how that 4-stroke cycle gets initiated. And what I'm going to do now is we're going to turn our attention over to this engine, and we're going to show you that, if I can put the camera back up here, and I'm going to show you that when we go ahead and get ready to start an engine, let's show you what's actually happening. Now, this is a Chevrolet V8. It's a 305 cubic inch V8, and I'll get here in the picture. And what we're looking at here is I want to show you kind of the energy of the 4-stroke cycle. That is, when we turn the key, in this case it has a push button start that I put on it. When I push that starter button, you'll hear the crankshaft spinning. I'm going to leave the ignition off so you can just hear the engine cranking. You'll hear the and that's the cylinders coming up and hitting compression. It kind of slows the speed of the crankshaft down. I've got a fuel hose over here going into a gas tank, so that's going to give me gas. And then after I listen to that for a moment, I'm going to go ahead and flip the switch, add spark, and the thing's going to roar to life, and you're going to get a sense of the energy of exploding gasoline and air in a combustible mixture of about 15-to-1. You're going to see flames coming out of here. There's no mufflers, so it's going to be quite loud. And if you were here, you'd be able to feel the energy of the engine running. One other thing I'm going to do first is I'm going to go ahead and pull a spark plug out with this 3/8 ratchet, 6-inch extension, and a spark plug socket. I'm going to go ahead and pull the spark plug out, and I'm going to crank the engine over, and I'm going to put my finger there, and I'll put the camera as close as I can. And I don't know if I'll be able to do everything. Hopefully I'll be able to do everything one-handed. And what I'm going to do is crank the engine, and then you're going to kind of see the compression. You won't be able to feel it, but you'll see me feeling it. So back here in the engine, I have start and switch. This is the ignition, so there's no spark right now because that's off. When I push the button, it'll crank. Let's listen to it. Here we go. So you can hear it's cranking. The starter motor over here on this engine is engaging a flywheel that's inside here, spinning the crankshaft. And on the front of the engine, watch when I crank it again, you can see that what's called a harmonic balancer, which is bolted to the front of the crankshaft. Watch it spin. So now you know the crankshaft spinning when you hit your push button start button or when you turn a key to start the car. Now what I'm going to try and do, if I can set the camera up and see if I can do it. Yeah, I think it'll work. There we go, and I'll come a little closer. Move my camera over, come a little closer here. And I'm just going to take my glove off and put my finger here. And you're going to feel you're going to kind of hear the compression. Here we go. You can hear it, you can see it pushing my finger. And that's just to give you a sense of how much pressure is built by the crankshaft spinning. I'm just writing in the spark plug, by spinning and pushing that piston up and down in that intake, compression, power, exhaust, 4-stroke cycle. I'm going to snug up this spark plug a little bit. And once I get it snugged up, I'm going to go ahead and put that spark plug wire on. So you've got a good view of this, to the side of the engine. So now to illustrate the strength of the combustion of a 4-stroke gasoline-powered engine, I'm going to go ahead now and come over here, and all I'm going to do is flip the switch. Ignition's going to go on. When I hit the starter, this thing's going to roar to life, And this, if you were here, would probably be your best day ever in auto shop, because the engine's really gonna take off, and you'll see here and see the engine, you'll feel it. I'm gonna hit the throttle, which would, this linkage here, if you were, when I push it, it would simulate you pushing down on the gas pedal, which is letting air and fuel into the engine, and the more air and fuel, the engine just roars. So safety glasses on, ignition's on. Here we go. 1, 2, 3. So I always like to say it's kind of an angry white guy thing. Just kidding. Anyways, so obviously it roared to life. The exhaust is coming out. What you're hearing is exploding gasoline and air. And if you were standing here, and I don't know what it sounds like when you're watching this on YouTube, but it's really loud. This whole room is vibrating. Obviously, the exhaust is really smelly. There's no catalytic converter on it to try and convert unburned hydrocarbons, carbon monoxide, and oxides of nitrogen into something reasonable for us to breathe. But I will take the camera over here, and I'll start it again. And I'm going to hold it right there, and you'll kind of see the flame coming out of the pipe right here as we start. Here we go. 1, 2, 3. So that's a pretty cold flame. It's a blue flame. It's not a real hot one. The engine's pretty cold right now. And one more time, we'll start it just for pastime's sake. Okay, that was pretty fun. So hopefully that illustrates to you the energy of the four-stroke cycle when we ignite air and fuel inside the cylinder. When it gets compressed by the movement of that piston coming up in the compression stroke, it gets very, very explosive. Obviously, this engine doesn't have any exhaust, so it's very free-flowing. It doesn't have a transmission or a clutch or anything like that. So it really revs hard when I open the throttle like that. Yeah. And so that's kind of an interesting thing. What I want to do right now, though, is do a compression test. So I'll come over here and I'll grab my compression test kit. And I think you can see it for me, so I've got a couple tools here. Doing a compression test is going to give us a way of, of measuring the engine's what we call compression, but we're going to equate that to the ability of it to make power. So how much pressure the piston in each cylinder makes going up, that pressure, when we add air and fuel, makes a more explosive engine. This engine, when it was brand new, ran about 150 pounds per square inch of compression in each cylinder. A modern four-cylinder engine might have 180 to 200 psi of pressure. So we're tending to make engines that have more pressure in the cylinder so that we can have fewer cylinders and a lighter engine, but each cylinder is making more power. If we can kill weight, we dramatically help our around town gas mileage. If we can and then by having fewer cylinders, we tend to kill fuel consumption for all-around gas mileage, whether it's on the highway, etc. So in order to do this, and I do have a sheet that when you're here, you'll know exactly, it has all the procedures on exactly how to do it. Basically what we're going to do, and I'm only going to do one cylinder, but on the sheet, it tells you to remove all the spark plugs and to do this compression measurement. So we'll take a spark plug out. I've got it on off to go counterclockwise and loosen that spark plug with this 3/8 ratchet and this 3/8 extension and the spark plug socket. It's a 5/8 spark plug socket, and that's the distance across the flats of the 6-point socket. And one unique feature to a spark plug socket, it has a little rubber boot in there, so when you unscrew the spark plug, it comes out in the socket. Here's a compression tester hose. It has a little Schrader valve in there, which is like on your bicycle tube. And I'm threading it into the little O-ring on there, just seals against the engine. I'm not cranking it in real hard, but just kind of lightly. Taking this quick disconnect, pulling it back, and we're going to read compression. So the right way to do this is to hold the throttle open wide open throttle. We're going to crank it 5 full cranks, and we're going to, the engine's not, I'm going to disable the ignition so the engine won't start. And we'll just crank it over. Now I'm going to put the camera down here, hopefully where you can see the gauge pretty easily. I'll bring it a little closer. And this will kind of help me. So I'm going to, actually I'll hold this up here so I can hold the throttle open. Let me adjust the camera up. And hopefully I'm going to use the gauge to hold the throttle. Now, if I can get this a little closer, you might actually be able to read the numbers on the gauge. So in the black, we're reading in pounds per square inch. So in case you can't see, that's 0, 50, 100, 150. So we expect it to be somewhere up in here between 100 and 150. I'll come in real close and hold it like that, but I don't have a way of getting it that close, I don't think. So let me do it like this. Let me hold it like here, and I'll hold it here because I actually want you to see the gauge as we do this. So I'm going to crank the engine 5 full cranks, and you'll see the needle pulse as I do. Here we go. Okay, now there's a little bit of delay, I think, in the camera and what you hear. But we got about 100, and it's a 1 mark above 100, so that's 110, and it's almost up to the second mark. So it's pretty close to 120 psi. There's a pressure release right here. So I push that and it releases it. And I'll do that compression test one more time. Here we go. So that time I got about 120 psi. This thing normally gives a little bit higher compression than that. And just a couple of comments. These compression tester hoses are pretty finicky because when you, I forgot to release the pressure there and then just disconnect it and pop. So because this is inside the cylinder, a lot of times carbon gets in this little valve here. And the consequence of that is that sometimes it leaks out a little bit and you don't get as high. So whenever if I'm doing a compression test and the measurement doesn't seem to make as much sense as it should, I'll go ahead and maybe grab a different hose or I'll grab a different gauge. So it's about 120 psi. A lot of times this engine, different cylinders, gives about 130 psi. But again, this is measuring the pressure of that piston going down on intake, sucking in air, and then it's measuring it when it compresses up on the compression stroke. And the more compression you have, the more powerful the engine is going to be, all other things being equal. I'm going to go ahead and screw this spark plug back in. On your shop sheet that you would have where you hear, you would go through and measure the compression on each cylinder after 5 full cranks, holding the throttle wide open, and you would have the experience of measuring that engine. So it's a really important test to do, in particular when you're, if you're thinking about buying a used car. Is it got good compression? And is that guy going to, is that engine going to have lots of power? So it's going to, or does it have potentially a problem inside the cylinder? So if we have low compression, that means that the piston rings aren't sealing against the cylinder wall, or the head gasket between the block and the cylinder head is not sealing around the combustion chamber, or one of the valves, the intake or exhaust valves, are not sealing and they're letting compression leak. So usually those are the things that we're looking for if we get a compression measurement and it's not doing what we want to. If we do a compression test, let's say we got 50 pounds of pressure out of this cylinder, and we wanted to try and diagnose further, I could pull the tester out, put a couple of shots of oil with an oil pump can, maybe a tablespoon of oil, redo the compression test. What the oil does, it goes around the rings and artificially seals the rings. So I expect the compression to jump up a minimum of 15 psi. So if this was, let's say, 50, and it jumped up to 65, then I would know that's really normal. Even a new engine will do that. I would know that the source of the low compression, which should be about 150 psi, was not the rings. But if I have a cylinder that's 50 psi and I put a tablespoon of oil and I redo the test, and all of a sudden it jumps up to 150, I know that the rings are not sealing well, and by putting the oil in there, I help them artificially seal. So I know that cylinder would have worn compression rings. So we'll talk about this in a lecture that we're going to do on what wears in an engine. That'll be probably my next presentation that I do for you guys. So again, I've shown you the heat of combustion, the energy of combustion of the four-stroke cycle, and then I've shown you the compression tester and how we can measure the pressure in the engine. It's valuable because we want to know the condition of the engine, or it's valuable because we're trying to diagnose why a check engine light's on and we have a misfire in the cylinder and we're wondering if something in the cylinders happened or there's engine wear such that it's not making the power that it should. Okay, that's it for now. We'll stop this thing and we'll go from here.